again guided by awareness and purpose, but about integrating a voice that is goal-directed, compassionate, and grounded in reality. The inner coach facilitates forward momentum, fosters learning under press. The words you speak to yourself aren't just harmless thoughts floating through your mind. They are biological events. Each internal sentence, whether it's a passing complaint or a declaration of purpose, is processed by your brain in the same way it handles any sensory input, as information with consequences. This information influences how your neurons fire, how they wire together, and whether they reinforce adaptive or maladaptive patterns. In other words, self-talk is not just psychological, it is fundamentally neurological. The brain listens, and more importantly, it changes. This is the mechanism of neuroplasticity. Neuroplasticity refers to the brain's ability to reorganize itself by forming new neural connections throughout life. This process allows you to adapt, learn new skills, shift behaviors, and even recover from injury. Traditionally, we associate neuroplasticity with external events, learning a language, practicing an instrument, or rehabilitating after trauma. But self-talk is an internal driver of neuroplasticity that is active all the time, whether you intend it to be or not. Every phrase you repeat to yourself forms a cognitive, behavioral loop that is supported by biological structure, namely synaptic strength and connectivity. When self-talk is negative, repetitive, and rooted in fear, shame, or criticism, it can strengthen neural networks associated with anxiety, learned helplessness, and stress sensitivity. These circuits often involve the amygdala and anterior cingulate cortex, regions of the brain that monitor for threats and govern emotional reactivity. The more frequently these circuits are activated by negative self-referential language, the more efficient and dominant they become in guiding behavior. It becomes easier to access self-doubt and harder to imagine progress. On the other hand, when self-talk is intentional and oriented around growth, encouragement, or solution-focused thinking, different networks are activated. This includes the dorsolateral prefrontal cortex, which is involved in planning and executive function, and the ventral striatum, associated with motivation and reward. Positive self-talk doesn't mean delusion, it means calibrating the brain's internal environment to support effort, persistence, and emotional stability. By doing so, you are reinforcing the circuits that help you initiate action, evaluate outcomes rationally, and stay on course during setbacks. There's also the concept of Hebbian plasticity. Neurons that fire together wire together. If you consistently pair difficult emotions or stressful experiences with internal language that is grounded in support or problem-solving rather than criticism, you are teaching your brain to integrate adversity with resilience rather than defeat. This pairing can change your emotional responses in future high-pressure situations. Additionally, the neurochemical response to self-talk is significant. Self-affirming or encouraging inner language can promote the release of dopamine, a neurotransmitter linked to motivation and learning. Dopaminergic activity not only enhances mood but strengthens attention and the ability to encode new habits. Conversely, negative internal dialogue often contributes to elevated cortisol levels, especially when it's repetitive and uncontested. This hormonal response over time alters brain structure, especially in the hippocampus, which is critical for memory and cognitive flexibility. It's also important to note that this neuroplastic effect of self-talk doesn't require conscious belief at first. Even if your encouraging inner voice feels unfamiliar or forced, the repetition alone can begin to shift underlying patterns of activity in the brain. The motor circuits and auditory language centers, including Broca's and Wernicke's areas, still engage and transmit this input across broader neural networks. This repeated engagement is how habits, even mental ones, are formed. Your brain is an active participant in every word you say to yourself, whether you speak out loud or silently in thought. Self-talk is not just an abstract mental activity, it is a neurobiological event that engages specific regions of the brain responsible for language processing, emotional regulation, and decision-making. One of the most profound realizations in cognitive neuroscience is that the brain does not fundamentally differentiate between self-directed language and externally directed communication. Whether you are speaking to another person or thinking internally, many of the same neural systems are activated. Functional MRI scans show that areas such as Broca's area, involved in speech production, and Wernicke's area, involved in language comprehension, are active even when you are just thinking in words. This means the inner monologue you carry throughout the day is more than background noise. It's processed by the brain as meaningful input, and this input can drive behavior, influence mood, and alter physiological states. What's particularly important is that this internal language doesn't stay confined to the language centers. It interacts dynamically with emotional centers like the amygdala and the limbic system, as well as with the prefrontal cortex, which is involved in higher-order thinking and self-control. Even when you are not consciously aware of it, your self-talk is running in the background, shaping the lens through which your brain interprets the world. This unconscious or semi-conscious internal dialogue plays a powerful role in constructing what is often referred to as the predictive brain. Your brain is constantly generating models and expectations based on prior inputs, both external and internal. If your self-talk is consistently negative, critical, or defeatist, the predictive model your brain forms will tend toward pessimism, threat detection, and avoidance. It becomes a closed-loop system. Negative thoughts create negative predictions, which then bias how new information is interpreted, reinforcing the original thought. This isn't philosophical, it's physiological. The brain's default mode network, which governs much of your self-referential thinking and daydreaming, is heavily shaped by repeated internal dialogue. When left unchecked, habitual thought patterns can become the dominant framework your brain uses when it is not focused on a task. This is why chronic negative self-talk can lead to what's known as rumination, a form of persistent, repetitive thought that has been strongly linked to depression and anxiety. The circuits involved become more efficient through repetition, just like muscles getting stronger with use. In contrast, self-talk that is supportive, calm, and cognitively flexible begins to lay down different tracks. When this type of language becomes habitual, the brain responds by modulating neurotransmitter systems like serotonin and dopamine. These chemical messengers influence emotional tone, reward perception, and executive function. Over time, this kind of internal language conditions the brain to expect possibility rather than failure. The input from your inner voice becomes part of the brain's feedback system. It's information the brain uses to determine how safe you are, how capable you feel, and whether to enter a stress or learning state. One striking example of this can be observed in high-stakes environments such as elite athletics or emergency response situations. Individuals who train themselves to use deliberate, constructive internal language are more likely to enter a flow state, a neurological mode characterized by reduced activity in the prefrontal cortex, increased pattern recognition, and enhanced task execution. Their internal dialogue functions almost like an internal coach, guiding their actions and regulating their physiology under stress. This is because the brain is responding to the tone and content of self-talk, just as it would respond to external cues of encouragement or danger. Self-talk even influences autonomic nervous system activity. Words that reflect panic or helplessness can shift the brain into sympathetic dominance, fight or flight mode, while calming, focused internal language can activate the parasympathetic system, promoting rest, recovery, and resilience. These shifts are not metaphorical. They manifest in measurable changes in heart rate variability, skin conductance, and cortisol levels. The inner voice, therefore, is not just a narrative device. It's a regulatory mechanism that the brain uses to manage threat, attention, and adaptive behavior. The language you use internally, voice that narrates your efforts, your mistakes, your goals, has a direct influence on your neurobiology. One of the most powerful shifts a person can make is the transition from an inner critic to an inner coach. These are not merely two styles of thinking. They are two distinct modes of brain function, each recruiting different cognitive, emotional, and physiological systems. The critical voice tends to be reactive, rigid, and rooted in fear or judgment, often amplifying the brain's stress response. The coaching voice, on the other hand, engages systems associated with regulation, problem solving, and motivation. This shift fundamentally alters how the brain encodes experience and adapts to challenge. From a neurological standpoint, the inner critic activates brain regions such as the amygdala, the dorsal anterior cingulate cortex, and the insula, all areas involved in error detection, negative emotion, and social evaluation. When you repeatedly engage in self-criticism, especially under stress, you reinforce a feedback loop that increases cortisol, narrows attentional focus, and elevates threat sensitivity. This can create a state where the brain becomes more tuned to failure and less receptive to learning. The critic voice may feel like it's pushing you to do better, but what it's often doing is saturating your nervous system with signals that say you are not safe, not competent, and not in control. Contrast that with the inner coach. This voice recruits the dorsolateral prefrontal cortex and the ventromedial prefrontal cortex, regions involved in strategic planning, emotional regulation, and self-reflection without judgment. When you adopt a coaching tone internally, you're more likely to trigger the release of dopamine and activate reward circuits in the ventral striatum. These neurochemical changes increase your sense of agency, enhance working memory, and help sustain attention over longer periods. The coach voice does not ignore mistakes. It analyzes them, extracts useful data, and directs focus toward improvement. It frames failure as feedback rather than a verdict. This style of internal communication also encourages metacognition, the ability to think about your thinking. Instead of being fused with the emotion of a setback, the coach voice allows for psychological distance. It provides the brain with a chance to interpret the situation through a constructive lens. In cognitive neuroscience, this is often referred to as cognitive reappraisal, a strategy shown to reduce activation in the amygdala while increasing top-down control from the prefrontal cortex. This not only helps in managing emotional reactivity, but also builds resilience over time. There is also a behavioral learning dimension to this shift. When feedback from the environment, including self-generated feedback, is delivered in a way that supports growth, the brain's plasticity mechanisms are more effectively engaged. The brain learns best when it perceives challenge, not threat. The inner coach creates an internal context of challenge, one that keeps the nervous system aroused enough to stay engaged but not so overwhelmed that it defaults into defensive shutdown or avoidance. This creates what some researchers call the optimal zone of neuroplasticity, where learning, adaptation, and emotional regulation co-occur. Importantly, the coach voice doesn't require external motivation to be activated. It can be trained through repetition, intention, and consistency. Just like physical training builds muscle memory, mental training builds neural efficiency. As the inner coaching voice becomes more dominant, it gradually rewires the default mode of self-assessment. The shift becomes automatic, which is a sign that underlying neural circuits have adapted. It's not about silencing the critic completely. Criticism has its plure and enables the brain to translate experience into growth pathways rather than stress pathways. The effectiveness of self-talk is not determined solely by the words used, but also by when and how those words are delivered. Timing and tone are critical parameters in shaping the brain's response to internal dialogue. These two factors influence not just psychological outcomes, but neurochemical states, autonomic nervous system activity, and the integration of cognitive and emotional processes. The human brain is highly sensitive to context, and context is created in large part by the tone of internal speech and the moment in which it is applied. Timing refers to the exact moments you engage in self-directed language. When self-talk is delivered during acute stress, such as moments of performance pressure, decision fatigue, or emotional overwhelm, it interacts with the brain's stress response systems in real time. These systems include the hypothalamic pituitary, adrenal HPA axis, which governs the release of cortisol and other stress hormones, and the locus coeruleus, which drives noradrenaline production. In high-stress states, these systems are already elevated, and poorly timed or emotionally charged self-talk can exacerbate physiological arousal, increasing heart rate, tightening muscles, and narrowing focus toward threat. In contrast, using calm, directive self-talk at the onset of stress can blunt the stress response and initiate a counterregulatory effect. This activates the parasympathetic nervous system and increases vagal tone, which stabilizes heart rate and promotes a state of focused engagement. The tone of self-talk is equally crucial. Neuroscientific studies show that the emotional tone of language, whether spoken aloud or internal, activates the brain's affective circuits. For example, harsh or aggressive tone in self-talk can increase activity in the amygdala, reinforcing fear-based memory encoding and heightening sensitivity to error. Conversely, a supportive, measured tone recruits the medial prefrontal cortex and anterior cingulate cortex, promoting emotional awareness, error correction, and behavioral flexibility. These areas work together to evaluate mistakes or challenges without triggering defensive or self-destructive responses. Importantly, tone shapes the internal narrative's perceived credibility and authority. When you speak to yourself with urgency and panic, the brain registers that message as a credible signal of danger. When you speak with calm clarity, even in high-stress moments, your brain interprets the message as a signal of control. This has downstream effects on neuromodulators such as dopamine and serotonin, which influence mood, attention, and motivation. The internal environment you create through tone becomes a regulator for your neurochemical profile, setting the stage for either fear-driven behavior or adaptive problem-solving. Timing and tone also interact with working memory and executive control. During stressful events, working memory capacity can become compromised due to increased limbic interference. If self-talk is delivered with clarity and in the correct moment, it can serve as a stabilizing force, preserving cognitive resources. Athletes, performers, and high-stakes professionals often train themselves to initiate internal cues, brief, purposeful phrases at key moments before action. These cues are not randomly applied. They are precisely timed to shift attentional networks and optimize the transition between mental states. This demonstrates that the brain does not just passively respond to internal language, but uses it to synchronize attention, perception, and behavior in real time. Another dimension of tone involves the emotional valence carried in your internal voice. A neutral but firm tone is often more effective than excessively positive or artificially cheerful self-talk, particularly in high-stakes or emotionally charged situations. The brain is attuned to authenticity, even in self-generated input. A forced or disingenuous tone can trigger skepticism or internal resistance, whereas a steady, grounded tone builds credibility within your own cognitive system. In essence, your brain is more likely to follow instructions from a voice that feels competent and emotionally regulated. Moreover, research on self-distancing techniques, such as speaking to oneself in the second or third person, shows that modifying the tone and format of inner dialogue can reduce emotional reactivity and enhance decision-making. These shifts change the internal tone from subjective and emotional to objective and analytical, activating regions in the prefrontal cortex associated with deliberate control and future planning. The modulation of tone through self-distancing also illustrates that how you say something to yourself often has more impact than what you say. The underlying emotional signal embedded in tone becomes a neural cue that instructs the brain on how to prioritize, interpret, and respond to internal and external stimuli. The default mode network DMN is a network of brain regions that becomes active when the mind is at rest, not focused on the external environment, and engaged in self-referential thinking, such as daydreaming, introspection, or recalling the past. It includes areas such as the medial prefrontal cortex, posterior cingulate cortex, precuneus, and angular gyrus. Although once considered a passive or idle state, the DMN is now understood to be a central component in shaping our sense of self, our habits of thought, and our emotional tone. This network is highly plastic, meaning it can be reshaped over time through repeated cognitive and emotional experiences, including the ongoing patterns of self-talk. When self-talk is repeated with consistency, it becomes embedded within the brain's resting state activity. The DMN does not randomly produce thoughts. It draws from the most frequently activated cognitive and emotional patterns. These habitual patterns become the default templates the brain returns to when unoccupied. If self-talk is negative, filled with self-judgment, fear, or hopelessness, the DMN will begin to reflect and perpetuate these themes. The more often these kinds of internal narratives are repeated, the more deeply they are etched into the resting state connectivity of the brain, reinforcing a self-image built on insecurity, self-doubt, and defensive prediction. Conversely, when self-talk is intentional, future-oriented, and grounded in emotional regulation, the DMN begins to mirror those qualities. This doesn't require excessive positivity or motivational slogans. It requires repetition, consistency, and internal coherence. When the inner voice adopts a framework of growth, curiosity, and resilience, these mental states become more easily accessible, even when the brain is not actively trying to generate them. The DMN shifts from a loop of worry and rumination to a more constructive baseline of reflection, integration, and planning. This change is not merely psychological. Studies in resting state functional MRI have shown that long-term engagement in structured cognitive practices, such as mindfulness or cognitive reappraisal, both of which involve forms of directed internal dialogue, result in measurable changes in DMN connectivity. Regions associated with negative self-referential thinking show decreased activity, while connections to regions involved in executive control and emotional regulation become stronger. This reflects a shift in how the brain prioritizes and organizes information during periods of rest or low external demand. The brain learns to default to adaptive rather than maladaptive states, creating a more resilient internal landscape. Neuroplasticity within the DMN is also influenced by frequency and emotional salience. The more emotionally charged a self-directed phrase is, the more likely it is to be encoded deeply and become part of the network's baseline activity. This is why patterns of harsh inner criticism or catastrophic thinking can be so difficult to dislodge. They have been encoded not only through repetition, but also through intense emotion. However, this also means that emotionally resonant positive or constructive self-talk has the power to rewire the same systems. When consistent self-talk is combined with an emotionally grounded intention, such as a clear purpose, a vision of improvement, or even compassion for one's own effort, the DMN starts to internalize those themes as a part of your cognitive architecture. In practical terms, this means that consistent internal dialogue does more than temporarily change mood or boost performance. It gradually alters what your brain does when you are not trying to do anything at all. Over time, this shapes identity. The DMN is deeply involved in forming the narrative sense of self, the autobiographical storyline that each person constructs. If your repeated self-talk reflects growth, capacity, and forward movement, those qualities become integrated into the subconscious scripts your brain uses to interpret experience. The self becomes aligned with those internal signals, not through effortful belief, but through structural and functional change in the brain's most fundamental cognitive networks. When we speak to ourselves, We are not just thinking, we are shaping the very architecture of our brains. Every word, every tone, every moment of inner dialogue creates a ripple across neural circuits that either reinforce limitation or unlock potential. Self-talk is not a motivational gimmick or a psychological side note. It is one of the most accessible, powerful, and biologically grounded tools we have to influence neuroplasticity, regulate emotion, and condition our internal environment for adaptation and growth. The brain listens whether we speak with criticism or with coaching, and the consequences of that dialogue become etched into our default patterns of thought, emotion, and behavior. When timed deliberately and delivered in a tone that conveys clarity and stability, self-talk becomes a lever to shift the nervous system from survival mode into states of focused attention and learning. It rewires the default mode network, which governs how we relate to ourselves in the quiet moments, not during crisis or performance, but when we are simply alone with our own minds. That default network becomes either a background of self-doubt and rumination or a foundation of resilience and forward momentum, depending on how consistently we've trained it with our internal voice. This is not theory, it is applied neuroscience. Your brain in every moment is listening, and the way you speak to yourself today is already building the version of you that will show up tomorrow.